There you go. All right. So welcome, everybody, to this special IEEE at SF State and San Francisco EMB Society joint event. Really privileged to host two amazing speakers with us this evening who are making an incredible innovation in rehabilitation treatment using wearable sensors. And they are Dr. Charmayne Hughes, who wears many, many hats and is an incredibly resourceful and knowledgeable CEO of Tiana Health Technologies, who is also the section chair for San Francisco IEEE. And we also have Emmanuel Gallegos, who is a senior software developer there at Tiana, and also a fellow IEEE member and an alumni of CSU CSU East Bay. And for tonight, we'll have Dr. Hughes and Mr. Gallegos lead this presentation. And at the end, we'll have time for a question and answering session. So please, if you would like to hold your questions until the end, that would be wonderful. And we'll try to wrap this up close to around 7 o'clock. We'll see how much time we need, but an hour should be plenty. So without further ado, I'll let Charmayne take the floor.
Great, thanks for that intro, Darren. What I thought I would do first is kind of give an intro to the company as well as some of the hardware components, and then I'll have Manny speak about the software side of things. And then after that, I'll come back and talk about entrepreneurship, especially because that is something that doesn't really get emphasized in engineering enough, because the critical part is that if you're making things that you want to be put onto the market, you have to really have a sense of what is going on from the business side so that you can actually be successful. So I'll share my screen. So Tenor is actually what we call a social enterprise or a social good company, where we're interested, of course, in making a profit for our shareholders. But more importantly, I think, is the fact that we're actually trying to make the world a better place. And so we're primarily focused on reducing global health inequities through the development of cutting-edge health technologies. Whether these health inequities exist in developing countries or even within developed countries, where we have these growing inequities between the rich and the poor. Because I'm a firm believer in the idea that it's, you know, we're born into a certain way of life, and for some of us, it's not our fault for where we're born or who we're born to, that we don't have access to health services or the money to get quality treatment. And so the company actually started from a trip that I made to Ethiopia. And in an early version of my life, I was working on haptic robotic systems. So these very heavy mechatronic systems, brushless motors, all this kind of jazz. And I was on a trip to Africa, and I thought, you know, could this be used there? But it was really quickly evident after about 4 days that they're just not going to be applicable. There's the high costs involved, the intermittent power supply that we see in Africa and other places, the dust and the humidity would really render these devices unusable after 6 months. And then, of course, with the large maintenance costs, these just didn't seem like a feasible idea. So I kind of turned my focus onto wearables and mobile application, especially given the proliferation of ICT and, you know, the decreasing cost of MEMS units. So this is the Tenor team. And so you'll see a couple of familiar faces. Here's myself. My technical full-time job is as a professor, but I spend most of my time working on the business aspect, and I will have my MBA in about a month's time. Most of you will know Dr. Zhang has a PhD in computer engineering, works primarily on human-computer interfaces, and has done a lot of work on prosthetics. Then we have our founder, Kimihiko, who is an entrepreneur who deals primarily with US-Asia markets. And Ram Dajurti is our advisor. And Ram is actually the chair of the IEEE Rochester section. He's an IEEE fellow and invited speaker, and he holds 15 medical patents. So he's pretty, he's a great mentor out there. And that's kind of one of the things with the business is you have to have somebody who's more experienced that can kind of guide you through all these sorts of things. And then on the second level, we have Manny, who went to CSU East Bay, just freshly graduated and preparing to go into grad school. Tran, who is finishing their master's at San Francisco State with Dr. Zhang, who deals mostly with the hardware side of things. And then Chloe and Mateo, Chloe is actually doing her PhD in Germany, and Mateo, who's doing his master's in kinesiology, who are more focused on what content needs to go on the app from the health perspective. So here's the problem with rehabilitation. If you have a stroke or a frozen shoulder or shoulder surgery, it's a really time and labor intensive process. And oftentimes it is, people just stop going to rehabilitation. And there's a number of reasons for this. It's about the transportation time. So if you're going for a 30-minute to a 1 hour physical therapy session, but it takes you 1 hour to 2 hours to get there, you're going to start thinking that the cost benefit ratio to yourself is pretty low. The second is geographical barriers. So individuals that live in rural areas, they just don't have the health services available to them. And so they would need, for example, to travel to an urban area just to get the treatment that they need. And so this is particularly problematic for individuals who are of low socioeconomic status because, you know, their time is money. How can they afford to get to the clinic to have the treatment, right? That's a gas. If they have children, they have to figure out what they're going to do with their children, whether they put them into care or babysitting, you know, and of course, if you live in a rural area, they don't have public transportation options available to you. And so this one of the reasons why rehabilitation is plagued by very low compliance, about 30%, and poor outcomes. People just don't get better, even though the science is clear. If you do your rehabilitation, you will get better. It's kind of how it works. And so you really have to understand the human psychosocial element of the problem here. And so when looking around at what these solutions could be, I've always thought that using context-appropriate technologies is the way to go. And from a business perspective, you have to think about it. How is the solution going to help two groups of people? The first are healthcare providers, right? So they would be the ones that would buy the subscription to the Tenor system. And so why would they buy this? Why would they use it? And part of it is that it saves them time, right? So they can assign videos, rehabilitation videos and educational materials easily. It allows them to increase their geographical reach. So for example, they wouldn't be bound just by who is in their immediate area, but they can provide rehabilitation services to individuals who live 2 or 3 hours away quite easily. And unfortunately, we are living in a capitalist world. And so another big draw for physical therapy clinics is that it helps increase their revenue, right? And a lot of places, that's what they're really looking for as well. On the patient side, the solution is really attractive for them. It saves them time and money. They don't have to go to the clinic as often. They can do it at their own convenience when they have the time to do it. And by having this control over their rehabilitation, it actually empowers them, it motivates them, and it kind of makes them want to keep engaging in rehabilitation. And so, again, there's many ways to look at tele-rehabilitation, whether it be via robotic rehabilitation, some virtual realities, or things of this nature. But all of us are trying to play in this global market of physical rehabilitation, which is about $125 billion market per year. And of course, some of those things you can't touch with the solution that we have, right? So lower limb we're not working on right now. So from this 125 billion, if we assume that I can pull in, you know, 4%, we should be able to get a revenue of 3.8 billion a year. And one of the great things about tele-rehabilitation is that we're not limited by geography. So we can have a sales strategy that works in China and the US and Singapore, et cetera, quite easily without actually having physical brick and mortar stores. So this is the Tenor product, and just kind of an overview of the sorts of things we have. I like to use the phrase, it's more than just an app. And so, of course, it has the standard features like the ability to create and assign personalized rehabilitation programs. But we can also, with this, you can talk with the patient either via synchronous or asynchronous multimedia methods, so voice, text, these kind of things. We also deliver health education resources to people through the application on disease-specific things such as diabetes, sleep quality, healthy eating, as well as other things such as that they need to know about their specific disorder. And the idea here is that we want to empower people and also help them learn about what health is, especially when we're living in this, this culture of misinformation and disbelief in science. I really need to push back against that. And so we also have the Tenor Sensor in here, and the sensor actually records information about arm movement, and that actually gets displayed back to the clinician and the patient using these analytics and visuals. And the idea here is that from the clinician side, that information from the sensor can help them with their clinical decision making in deciding whether they need to change and pivot to a different way of providing treatment, or whether they need to increase the complexity and the difficulty of the exercises. And so the component in that sensor that we really work with is an inertial measurement unit. And these have really come into vogue in the last 10 years, and they're very attractive because the cost has really dramatically decreased. So an IMU consists of we have a 10 degree of freedom IMU, has an accelerometer, a gyroscope, and a magnetometer. IMUs are great, but they also have their own troubles, especially when it comes to signal processing. So the accelerometer, for example, is very sensitive to noise. And so that's why if you look at this acceleration trace here, you can see that you get this big spike here, which could be from banging something on the object, you know, moving your arm. All of these sorts of things can really cause some issues with the accelerometer. The gyroscope is subject to bias instabilities, right, and random walk. And so what you tend to see with a gyroscope is you get this long-term drift. So if you leave the gyroscope on a table for a long time period, it's actually, the signal will drift upwards. So you have to account for those two things. And then the magnetometer. So the magnetometer, as the name suggests, is dealing with magnetic fields. And so the big issue with magnetometers is the warping of the magnetic field. So for example, the magnetic field where I am in Singapore is actually, because we're on the equator, is very different from in the United States. And so you really need to understand what the hard metal components are relative to your latitude and longitude. And if you're going to be using it in different places, you have to have a component of your algorithm that's going to deal with the hard metals. The other part of the magnetometer is the soft metals that are in the environment. And so, for example, if you're working in a particular environment where there's a lot of steel or metal, that can actually warp the magnetic field and cause a distortion on what you're seeing on the magnetometer. Okay? And even worse, of course, is when your magnetic field is inconsistent. And this would exactly be the case with telerehabilitation, because the magnetic fields in people's home environments, wherever they are going to be different. And that's why working with the magnetometer is actually pretty complex, and should not really be used if you're going to be using it outside of the laboratory or in these environments where the magnetic field is inconsistent. So of those three components, the one that we really need to deal with is the bias and stabilities in the gyroscope. And for most of you out there, let's take this acceleration profile, which is what, of course, you are deriving directly from the accelerometer. And what you can see is that over time, if you were just to integrate and get that velocity component from the acceleration, you'll notice that you can see that they're actually drifting, right? So in the Z component, we're drifting upwards. In the X, we're drifting downwards. And so that is, you need to deal with this in working with your signal processing. Because if you don't, when you actually go and do the resultant of these 3 vectors, you actually get a velocity profile that looks really weird, like this. Okay, and this is one of the reasons why it's not just a simple case of numerical integration. Numerical integration is not the solution. You need to deal with the bias and the drift that you're getting in the IMU. So for example, that what we have at the start here, this puppy here needs to actually be brought down to the start level, okay? And so the way we deal with this and is a little bit different from competitors. So here's just some pictures of other competitors who are working in the wearable sensor space. You'll notice that all of them are using multiple sensors. And what they're using multiple sensors, usually having a kind of a base IMU on the chest, and that kind of serves as that reference point. Otherwise, they'll use a transceiver and a receiver placed in a known location, which will actually help them set their global coordinate system. We chose not to use this approach for a number of reasons. One, if you're dealing with people who've had a stroke or have other kinds of injuries, having them wear all of these markers is quite time consuming, especially when they only, some of them may have only the use of one arm. And the second one is that, you know, it increases the cost of the system for each sensor that you're going to add. But the idea here is, if we take a look at this one, which is from XSense, you would basically have to calculate the joint angles and the rotations at each of those segments in order to get a full map. And so we have spent a lot of time developing this with using a single sensor technology. And our solution is just to use the accelerometer and the gyroscope data. And the solution works in 3 ways. The first is we implement a 0 angular velocity update to the gyroscope, which basically means that we need a stationary or a non-movement at the start and a stationary period at the end. And what that allows us to do, let's say this is the normal signal, that allows us to actually reduce that drift that we're seeing. Okay. And so the second step is to fuse and filter the data using an altitude heading algorithm. Otherwise known, you may have heard about it in terms of a Kalman filter. And then the third part is you actually have to align the sensor, which is the local coordinate system, to the Earth or the global frame. So if I just show you the schematic on the right, it kind of shows you how all of these elements get brought in. So basically we take the vectors from the accelerometer and the gyroscope and we put them through a low pass filter. This is especially critical because human biosignals are notoriously noisy, and you have to remove those, as well as, for example, the flickering of the lights at 50 or 60 hertz, depending on the country you're in. After we trim the data, because that always has to occur, we actually calculate the stationary periods, again, at the start and at the end of the movement. And once we get that, we can actually apply that AHRS filter, which fuses the accelerometer and the gyroscope data, and using the gyroscope data to account for the drift in the accelerometer. And then because the sensor is worn on the wrist, it has its own coordinate system, the sensor coordinate system. But when you're starting to work with kinematics, you need to know in order to remove the drift, you need to actually translate it to the Earth frame velocity. And this requires some intense mathematics to do. And once you kind of get to that stage, then you can remove the drift, right? So you need all of those elements in order to remove the drift and set your signal back so it's, you know, in alignment. And then once you get to that point, then you can actually calculate some of those kinematic variables that are important to clinicians, which are things like movement time, movement smoothness, and peak velocity. And so I don't mind sharing with y'all, because most of you are students, this took us about 1.5 years to achieve. It's some pretty complex math, and there's probably a reason why most laboratories and most firms prefer to use multiple sensors, because they don't have to deal with a lot of these issues. So when looking at what sets us apart, then it's really about the single sensor technology. which allows us to provide it at a better price, as well as the powerful analytics, right? So a lot of the things you're seeing out there on the market, they might be able to measure your range of motion of a joint, or be able to detect between different activities. You know, are you reaching, are you grasping, all these sorts of things. And so what we're able to do is provide powerful analytics. And I'm going to show you just how powerful the sensor is. So the first thing we did once we developed the sensor, and here's like our second version, which was like a very, very chunky box looking thing. We tested how accurate our sensor was compared to a motion capture system, which I have back in my lab in San Francisco State. And the system is about $60,000, whereas the material cost for this first sensor was less than $20. And so over here, I'm showing you these are correlation plots for two different activities. And then over here is a blind Altman plot, which basically shows the level of agreement between the sensors. So Vicon here and the sensor on the bottom. And what you can see is that it's basically perfectly aligned on the orthogonal. So the correlation in the movement time for each trial for both the Vicon system and the sensor has extremely high level of agreement and correlation between 0.92 to 0.99 with respect to correlations. And again, we can see that the mean difference between the sensor and Vicon across all types of movement time is also very, very tight. And so let me show you what that looks like with respect to a velocity trace. So if we were to plot the velocity, right, so we've done all of that integration and the all of those processing steps, we can see this is a basic velocity trace for a reach to grasp movement. So a person starts on the table and then they reach for a block and then they move the block up into a tabletop and then they move their hand back down to the table. And so that's why you get these three velocity traces. And so what you can see here is that the Vicon system, which is in red, and the sensor at the time, which was called Outreach, is basically on top of one another. And this illustrates here that our sensor is as accurate as a $60,000 system. And this is some work that we published in Frontiers in Bioengineering and Biotechnology back in 2019. And then in the second step, what we had to do was see, you know, okay, so we know this can be used for motion capture, but how sensitive is it? Can it actually detect between different levels of stroke severity? So I want to show you two patients. These are some patients in Ethiopia. And I'm going to visually show you the differences. And then I'm going to show you what that looks like from data collected from the sensor. Okay, so this is an individual who has a mild stroke. And so his movements are a little slower than you and I, but the impairment isn't too bad. Okay. In comparison, let's have a look at this gentleman. So this gentleman has a more severe stroke. He has problems with his grip. And you can see he has this discoordination of the limb. So his arm is very hard to move. He has power problems, but also incoordination. And so when we record this with the sensor, we recorded from their unimpaired arm to use as the baseline, and then we looked at their impaired arm. So what you can see is on the unimpaired arm, those velocity traces look very, very similar to what we saw when we tested it in the laboratory, right? So even in the field, we're getting accurate movements. Then we want to compare it to what their actual arm looked like. So this is the velocity trace for the individual who was on the left, who had the mild stroke, where even though it didn't seem like, you know, just by looking at the video that he had issues moving, the sensor can actually pick up the smoothness or the lack of smoothness in his movements, right? And this is the benefit, is understanding that, you know, you can go to the clinician and they can watch you do movements, but where's the sensitivity, where's the fine grainness of the analysis? And then, of course, for the gentleman on the right-hand side who had the greater level of arm impairment, this is what his velocity trace looks like for that unimpaired arm. And from that, from this trace, we actually pull out all of those variables that we need to know. We can see that his movements are a lot more jerky, so they're less smooth. His peak velocities are also a lot lower, right? Which is typically what we see for stroke patients. And so the idea here is that using our sensor, we can actually detect between different levels of stroke impairment. And then what we can do eventually, and we're setting up for clinical study on this, is we want to get people who start at this level here. We want to slowly, over that rehabilitation period, get them down to their arm movement like this. And then eventually, so that it should look like that. And so this is the idea of what the sensor can do. It can provide the clinician as well as the patient with a real fine-grained analysis of how rehabilitation is going. And I think by seeing the numbers and seeing the progress, that's motivating, and it makes people want to continue doing their rehabilitation. When they do their rehabilitation, they're going to get better, they're going to feel better about themselves, and they're going to have a better quality of life in the long run. Okay, and so that's kind of the hardware side of it, and I'm going to let Manny now, because I know that was a lot. That's kind of basically, by the way, that's like 3 or 4 years crunched into however long I've been speaking. So I make it seem easy, but Dr. Zhang will tell you that it's a lot of period of what is going on and going back to the drawing board and trying to figure things out just to get to that stage. I'm talking like it was quite easy, but it was very, very hard, all things considered. So, and then basically what happened was, I worked on haptic robotics, and I was like, how hard can making a mobile application be? And it turns out it's very hard, and I don't have the skills for that. And here's the beauty of IEEE, by the way. I'd met Manny through some of the Region 6 things that we have in IEEE, and I just happened to be on LinkedIn, and I saw him talking about this COVID-19 diagnostic app that he was making as a school project. And I remembered him from meeting with him, and I was like, can you do this stuff, and are you open to work, kind of thing. And so that's the beauty of being an IEEE member, right? It's about the connections, it's about the networking. And so that's why it's good to be an IEEE. Okay, so I'll let Manny talk about the software part of it, because I don't know any stuff about that one.
Sure, thank you for that. I just got to say, that was actually the first time I've heard Dr. Hughes give that whole speech about all the technology that went into that sensor, and I'm also pretty floored. That's awesome to know how much effort went into that. So compared to that, I feel like my job is really easy. I know Shar just said that the software engineering side felt like it was impossible. To me, that what she's doing is the impossible part. As a software engineer, my job is just to build the interface and the backend for the Android application that you saw in the photos, right? So the sensor is going to connect to this application via Bluetooth, and the job of the application, along with like connecting the patients to their clinicians and providing all of that feedback in the form of charts, is really to translate data from this sensor, which comes in the form of a CSV file, and figure out how to translate that code into Java, which is what's usually used as the base for Android development, Java or Kotlin, and get that working from the Android mobile platform. So right now, that's actually what we're moving into looking right now. So I haven't done too much work in parsing this code for Android development, but it's what I'm researching. The rest of the app has pretty much been developed. Most of it, we're doing some restructuring on the back end, which is definitely interesting. There was a lot of compliance with like regulations for health applications that we didn't realize would be such a big stumbling block. So that's something that we're looking into right now and working with another team to work through that. But from the software engineering side, like a lot of what I'm doing is translating code now that was written in MATLAB, which is right the original like math processing code for all of these intensive calculations that Shar mentioned, and figuring out how to translate that to a way that can run on Android. There's a couple ways we can do that. One is to literally just try to translate the code over into like Java packages that can do similar things as what MATLAB does. Another way is to figure out how to add dependencies in Android that will let you run the MATLAB code translated into C, because there are ways to translate MATLAB code into C, and there's ways to run C code from Java. So there's kind of like this multi-step process of translation there, but that is probably going to be what we're pursuing. But it's definitely been interesting. I mean, I went into this as a student, right? So it wasn't something that I've ever had professional experience in as a software engineer. Like Shar said, I was just working on a research project with some graduate students down at CSU East Bay. So jumping into this in like as a professional career right now was a bit of a shock. And I think it's a little bit different than what a lot of people would get as an experience going into industry at like an established large tech company, you know? And I think we'll go back and talk about that a little bit, about, you know, comparing what the pros and cons are of like going into trying to get into established company versus going for a startup. But I will definitely say that I've learned a ridiculous amount over this whole period. Like I definitely learned a lot, like, you know, in my software engineering courses in school, but without a doubt, the amount of knowledge that I've acquired in the last like 5 or 6 months working on these applications has like dwarfed all of that, you know, all the things that I learned in my software engineering courses, you know, needing to look up all of these things yourself and build these systems from scratch. You realize there are a lot of design questions that you don't initially anticipate are going to be relevant. But as you start building the system, you realize there's so many different ways I can do this. There's so many different ways to make, you know, just to connect like a patient with a clinician, like what's the most efficient way, what makes the most sense. Well, and a lot of that has to do with communicating with Shar. So a lot of my job is to communicate with Shar and ask like, so how is this going to work? Like, who is the one who, you know, initiates this? Is this the clinician, you know, in their actual clinic who is going to set up the profile for the patient? Is the patient going to set up their own profile, right? That kind of thing. So it's honestly, I thought that it was going to be a little bit simpler than it ended up being, but I feel like I've learned a lot over this whole experience and I'm definitely happy for it. So like I said, I think we are going to talk a little bit about the startup enterprise and all of that. So I think I'll save discussing like the pros and cons of like startups till we have that discussion. I would also like to throw in that I have been applying to graduate programs and I've learned a lot about that definitely over the last semester as well. So even though it's not a part of this conference at all, I will say that if people do have questions about like grad school process and applying to grad school, maybe we can tack those on at the end if there's time, if that's something that people are interested in, because I think that's kind of the third path. You know, you can go into industry at an established company, you could look into a startup, or you can continue your education. So if you have questions about that too, I'd definitely be happy to field those as well. That's about all I have for the software side of things.
Sorry, I was on mute. It happens every time. And so one of the things is that I've realized, you know, after I got a PhD, and I thought I would actually be a career academic. That's kind of what I wanted to do. I wanted to be a professor and just work in a laboratory and make things. But, you know, on about the second system that I developed, we realized is that, you know, a lot of these things that we're developing just never leave the lab, right? We have these big aims. We're going to help individuals with stroke or do this or do that. But we've tackled it from an engineering perspective, but we haven't tackled the rest of it. And that's what makes a startup really, really difficult. And that's why when I came to San Francisco State as a professor, I actually enrolled in the MBA program, and, you know, which I'm about to finish, which has provided me with these kind of unique perspectives to actually help or increase the chances of being a successful startup. I do want to preface this thing where I think when we think about startup, we think about like Facebook or, you know, Uber or Airbnb as this kind of glamorous lifestyle where you get to hang out in hoodies and, you know, play foosball in the back and beers are there from 3 p.m. kind of culture. And that is not my kind of startup because that involves a lot of money that startups don't have. And so, especially when you're working on hardware, software, you know, if you have an app, things get pretty easy because you're just building the app. And once you have the app, you can show that to investors. And if they think there's promise, they'll give you money. Hardware and software integration is more complex. It takes longer to develop. And especially if you're working in the health field. So working in the health, because you're working with patients, they want to know that you've done clinical testing, right? They want to know that it works in the patients. And that is what takes a lot of time. And when you go to investors, they want to see, you know, they want to see the product, but they also want to know about your business plan. How are you going to market it? Who's your competitors? What are your timelines and what are your goals? And so as the CEO, I would much prefer spending my time doing more technical stuff, but I actually spend a lot of my time working on other elements of the business and doing a lot of strategy and making decisions. And when you're at a startup, these decisions are extremely important because money is extremely tight. And so you have to decide, you have to make these decisions which could, lead you to success, or they can actually lead you to a lack of cash flow, which means you can't pay people to do things, which means that the business goes bankrupt. Okay. And so this is another idea for those of you who are having engineering degrees is to complement that with an MBA. Now, is it as technically and analytically hard as engineering or computer science? Absolutely not. Right? Don't expect to be completely mentally challenged the whole time. But it's a very different way of thinking about things. How do we market this thing? What are our competitors? How are we going to do the financials? What about our supply chain? So for example, our first PCB that we had designed came from China. And then when they came to the United States, it took about 2 or 3 months of troubleshooting. Like, why won't this thing work? Why aren't we getting the signals that we expect to get from it? And, you have to troubleshoot. Is it because we changed some of the components to make it smaller? Like we changed from the TIVA, which is, basically like Arduino and very useful in engineering courses. We changed it to an ESP32, and then we made the PCB. So is it that? Is this huge change in these systems? And as it turned out, there was a problem in the manufacturing of the PCB. And so initially I'd heard from other individuals who are also doing hardware that they also had some issues with Chinese manufacturers, especially if you're not in the region and especially if you don't speak Chinese. And so my initial thought was, okay, I'm here in Singapore. It's a technology and science hub. So we'll look at getting our new PCBs made in Singapore. But then we just got the quotes back from the new PCB, and Singapore was going to charge, their quotation was for 10 PCBs, $2,000 US, which is it's just frankly a ridiculous price to pay for a PCB. And so even though I wanted to go with Singapore, just from a cost perspective right now, like the strategy is I can't afford to do that. So we'll be working back with the Chinese manufacturer, but making sure that the way that they're shipping it, the way that the components are done, and on that PCB is accurate and up to our standards. Because it's a strategy of, can we risk losing time if it doesn't work versus the amount of money that goes in it, especially at these critical stages where you're not buying in units of 1,000 to 10,000. If you're buying 10, things are always going to be expensive. We don't have economies of scale at that stage. And so, there's this kind of statistic that more than 90% of startups fail in their first 5 years. And it's even harder, I think, if you're doing hardware and software integration. And a lot of it, it doesn't really have to do with the technology. That's a really small part of it. The bigger part of it is the lack of product market fit, and as well as marketing problems. So I noticed when I talk to engineering students, they try to solve problems for which there is no problem, or they try to make a solution for something that doesn't exist, right? And so when you're starting to think about what you want to develop, you better make sure that people are out there, that they want it. No, so it's not about what they need, it's about what they want, what they're willing to pay for. And how are you going to market it to them so that they should purchase your product over what's out there, right? So because some of the most complex systems out there, people don't use because they're like, this isn't useful for me, right? Think about something as simple as the electric toilet, the toilet bowl thing, where it flushes the water and all that kind of stuff. It's a great invention. It's probably way more hygienic, all things considered, but they haven't actually got any kind of markup, right? They haven't actually got to the sustainable level where it's in everyone's houses. And so that's this kind of thing where I'm trying to push more for in engineering education, is to bring in this entrepreneurship. start thinking about the problem before you do the technical components of it, right? Because you have to think about how much do I want to sell this thing for? How much can I sell it for? And how much are these components going to cost? You know, I worked at the Technical University of Munich and at Nanyang Technological University in Singapore, where we would make robots that cost, just the material cost would be $100,000. Well, if the cost of the materials is $100,000, you know, how much do you have to sell it for in order to cover, you know, the cost of materials, people's salaries, your marketing costs, all those things just really add up. And that's why, you know, at this stage, everything is a strategic decision. And then about entrepreneurship, you know, if you think about it kind of like a maze and you want to get from where you are here up to success, there's all of these things that you have to think about, especially from the CEO perspective, where on a daily basis, I have to think about, do I want to reach out to investors? How am I going to fundraise money? Do I want to bring more people on at this stage? What should our focus be on right now? What should our focus be on in 3 months? What market do we want to enter? What about if there's an investor who wants to offer us, you know, $1 million, but they're not interested in helping underserved individuals, right? Those are the kind of decisions that I have to work with on a daily basis, which is why it's probably not my most fun activity, because it's very stressful. I spend the bulk of my time thinking about money and where money goes, and I don't enjoy that part of it. Yeah. And then to finish off with those two things where I was talking about the product fit, right? Consumers matter. And so for Tenor, it's a really great time because prior to COVID, there were these, people didn't want telerehabilitation, right? So in 2019, only 11% of consumers in the United States had used telerehabilitation or telehealth. And now you have 76% of people who are interested in using it going forward, right? And it's just because that there's this kind of shift in consumer preferences that were forced by COVID, right? And secondly, from a provider perspective, when COVID hit, because America didn't have the regulations set up, they couldn't do any of their, you know, people weren't coming to the clinic, right? Because they didn't want to be exposed to potential COVID, as well as the fact that there were, you know, local and city and state level regulations about how many people can actually be in a certain space. And so there's been a, you know, a rapid increase in the perceptions about telehealth and what it can be used for, as well as people actually wanting to integrate it into their current business model, right? So you have to understand that, will people buy this, right? Will they use it? And that's the critical component. Part of it is also timing. Like I said, if I tried to do this back in 2009, it probably wouldn't be possible because people would have been like, you can't replace the physical therapist, right? But these things shift with time. And the last thing, which is very, very important for telehealth applications, is regulations. And so, like I said, prior to COVID, it was very, very hard for a healthcare provider to be reimbursed for telehealth, right? And of course, in the United States, we have all of these different state rules. So it was a very, very complex system, right? And with COVID, they actually started to do these emergency regulatory changes because people still needed healthcare, right? And so, and these kind of regulations are looking to become permanent, which is great for Tenor, right? So now this is what's changed. The big things that have changed are that telemedicine visits can be provided to patients in their own homes. Boom. So that solves part of the problem. And that visits aren't limited only to rural residents. So anybody, you know, you could live in Chinatown in Singapore, Chinatown in San Francisco, right? Which also has its own barriers when we talk about accessibility, but an individual there could receive telerehabilitation, right? The requirement that the provider be licensed in the state that the patient's practice is waived. So that means, again, you can open up your geographical reach. The clinic can make more money, which means that using the Tenor system is going to be much more attractive to them, okay? And then basically it's about, they can be applied to all sorts of things. They can get reimbursed because reimbursement is a critical component. Physical therapists, occupational therapists aren't going to buy a system if they aren't going to be reimbursed from Medi-Cal or Medicare or from private insurers, because just relying on out-of-pocket costs, right? So an individual who come in, pay $70 or $150 actually in San Francisco, you aren't going to have the number of customers who pay personally in order to make it worth your while. And so these are kind of the lessons that I've learned probably in the last 3 years of doing my MBA, that you have to account for all of these other things other than just your technology, right? Because your technology can be great, but if there's not a market for it, if there's too many regulations, you're going to just keep hitting your head against the wall and no one will invest in it. Okay, so that's kind of my pitch deck about how stressful a startup is, basically.
Excellent. I think, Emmanuel, if you wanted to share just a little bit about the work experience, I think you were going to touch on that as well. And thank you for sharing all of that, Dr. Hughes. That's, yeah, it's amazing. It's just such good insight.
Yeah, sure. It looks like we're running a little short on time. So just to make sure there's a little bit of time for questions, I'll just say, I mean, a lot of the stuff is kind of obvious when it comes to, approaching joining a startup from, the employee level, right? Like, obviously, there's a lot of complexities to starting your own startup, and I can't speak anything to that. I think Shar spoke to it pretty well. But from an employee perspective, you have to analyze like what the company is doing. Is it something that you're interested in? Is it a product that you believe in? Because you have to realize that the initial compensation is likely not going to be as, as high or as reliable as, a job at like some established tech company, right, where they'll have more benefits, for example. On the flip side, working with your boss in a little bit more intimate manner, where it's not too many people in the company, there's more room to, have some flexibility. And obviously this will depend on who you're working for, like what the company is like. But like working with Shar, she offers me a lot of flexibility in the work that I do as long as we get things done. So as a student, that was very attractive to me, right? I could do my research, do my work, apply to grad schools, and then do, work on weekends or work on evenings whenever I had time. And I could, get in the work and get things done and, get some experience. One other neat little bonus is that you get to kind of make up your own title if you're at a startup. So, right, like I think at one point I was lead software engineer, and then now I'm senior software engineer. I mean, I've been working at this for less than a year, but right, I'm technically a senior software engineer because I'm the most senior software engineer in the company, right? So that's my position. And of course, companies will recognize, oh, this kid's coming from a startup. He's probably not, 5 years experience as a staff software engineer, but, there's definitely some great experiences to be held. Being in a small company, you get to see a lot of things that I think would probably be obfuscated from you if you were just sort of a lower level employee, at least for the first few years. Get to see how the whole system is run for the top down. And if you're interested in pursuing your own startup somewhere down the line, it gives you a ton of insights into how that whole process works. Like I personally am definitely interested in starting my own business somewhere down the line in my future. So being able to be a part of a startup and see what that's like, is again some more invaluable experience. So you really have to weigh, all of these options when you're looking at. I'd say when it comes to a startup, it's really important that you analyze exactly like who you'd be working with and what the company's doing. Like it's very important, as opposed to like they're going to work, for Cisco or IBM. It's like, right at that point, it comes down to more compensation, and it's, and maybe like what the job title is. But there's a lot more to consider, I think, when you're considering that step for going to a startup. So that's what I'll say about that.
Beautiful. Well done. Short and sweet. Thank you. So yeah, we should open the floor now. If there's any questions from the audience, you can try and use the raise hand feature. Just so it may not be too out of order, but if there's also not a whole lot of questions, just feel free to unmute and ask away. And maybe if people need a moment to gather their thoughts. One thing that I was thinking about is, so I noticed, Dr. Hughes, you talked about the transition from, the haptic feedback robotic system into this more wearable sensor with an IMU. were there other sensor systems that you were looking at as potentials? Because I know, for example, MyAware is a popular thing where people are looking at the EMG pulse data or whatnot. But yeah, have there been other sensors you've explored, or what are your thoughts about that?
Yeah. So Dr. Zhang and I talk about this all the time. And so, I'm not a engineer by training. I just have these positions in IEEE and kind of got into the field because I like technology and really developed the skills later on. And so when I was at the Technical University of Munich, we were developing a cognitive rehabilitation system for individuals with stroke who have motor planning difficulties. And so we looked at using, for example, the Connect sensor to track movement and track behavior. We've also used sensors, sensorized objects and things of that nature. But the problem with the Connect, for anyone that they don't sell it anymore, but back in the day it was about $200, and it sampled at around 29 hertz. So, when somebody says we sample around, it doesn't really work, because in order to do these numerical integration and differentiation, you need to know what your sampling rate is. So, I thought about that. I've worked a lot in EMG actually, and the problem with EMG is not as easy as people think it is, right? So especially for the upper body. So if you're dealing with the legs, it's easy because you've got these massive thigh muscles, your calf muscles are very prominent. But when you're talking about the forearm, you have all of these muscles in there. So you get a lot of crosstalk. And so that's what makes it hard. And also to apply it to the musculature takes time. So you're looking at like a 30-minute setup time to apply electrodes in order to actually get the signal. Plus that the EMG is the signal to noise ratio is insane. So you have to amplify that signal, right? Like nobody's business. That's why typically in the lab we use these kind of custom and expensive EMG systems. I know that when I first started working with Dr. Zhang back in the day, we were using the Myo armband, which calls itself EMG, but it is not EMG. What it's basically looking for is just electrical activity, but it doesn't actually specify it, what muscle it's coming from. So that's why that kind of stuff is limited to gestures. You couldn't take that information and then apply it to how well a movement is doing or tracking the kinematics. Kinematics is really difficult because you need to know, for the case of motion capture systems where you're capturing 3-dimensional position, and then you do your algorithms from there. Whereas the IMU is capturing accelerations and then you integrate downwards. And so you have to think about what do the people need? So actually looking at what customers want and then developing the systems from there. And like I said, I started in robotics because the IMU systems just weren't that good back in the day, right? And so technology is always advancing. And so that's why it's good to be looking at these new sorts of things. Like I see even now PCBs are, they're moving from the plastic board into actually flexi materials, and that's where material sciences comes into play. Yeah.
I have a question. My name is Martin, and I was wondering about, I know you talked a little bit about the regulations on medical, with the app when you have to develop it. What about the legal background on, having the title for your company? Like, do you go to a lawyer, or how does that start?
Yeah, so that stuff, Martin, you can actually do online, but there are some decisions to be made. So we started off as a partnership, right? So between me and another co-founder, and I honestly wish that I was very naive coming into it, and I'm a very, I would say, trusting person, and that's what's kind of gotten me into problems. Manny and Dr. Zhang know about this, in being too trusting with people, and I really should have pushed for way more equity in the company. But so we started that way, but then when we got our first angel investment, we had to actually change it from a LLC into an incorporated company. And at that stage, we went through a lawyer. Fortunately, and this is why networks are super important. We knew someone who knew someone. And so we were able to get all of our legal stuff done for $350. Because what we needed is to fill out all of the get all the contracts and stuff to get it to an S Corp. Then we originally as a partnership were in California, but problem with California is that your high tax fees each year that you have to pay as a business. Again, just bleeding money every day and just losing money just sitting here. And so we decided to then incorporate in Delaware, which is cheaper, which is what a lot of companies do. And then we actually applied for a business certificate to work in California. The problem with, you don't necessarily have to go through a lawyer, but trying to do it by yourself is very, very hard. So that's why having a mentor or somebody who's done this sort of thing before is really, really helpful. But those lawyers fees, man, if that was a career, if I'd thought about my life more seriously, I would have been a lawyer, because you can charge insane rates, because even to look over something, they're like, they round up to the hour. So just to look over something, they're like, that's $350. I'm like, oh, so yeah, but those are critically important things. Yeah.
Thank you.
And to tack on a little bit about the health aspect and the legality of that, when it comes to regulations for like the app side for whether it's considered like a health application, it really comes down to what kind of data is being stored and transferred. Like if that data has private medical record information or anything to do with like diagnosis or anything like that, that's what's going to qualify it as a health application. And, it's going to require all of the really strict cybersecurity rules. It's not so much like the name of the app. It's more like what is actually happening inside, what kind of information is being transferred and stored. And that will determine if you need to go through all those really intensive regulatory procedures.
Yeah, and that's a good point, thinking about your supply chain, right? Is that what are your core competencies of your team? I clearly could not make the thing HIPAA compliant. I just don't have the skills. Manny and I talked about it, and he's like, maybe I could, but maybe not. And so we decided to outsource to Poland, where, by the way, Eastern Europe is, if you're looking for cheap programmers who are pretty good, that's the new place to go. And so that's costing the business about $25,000 just to make this application HIPAA compliant, but it's totally necessary because no one's going to buy it unless patient data is safe. So again, that's a strategic decision that you need to consider. But yeah, $25,000 versus trying to play around and figure it out ourselves and waste precious time,
and get sued.
Yeah, exactly. So it's not so much is it HIPAA compliant, it's if you get audited. If you get audited and it's wrong, there goes your
fines.
Business, basically. Yeah.
It's ridiculous. Yeah. For a good reason.
Do we have any other questions?
I know it's a lot to take in, but I think Dr. Zhang and I started working on this in 2016, playing around with some ideas, and really got serious about it in the last year and a half. But we're academics primarily, so we're really conservative. We're not going to start a business until we know the science and the engineering is solid. Yeah.
Well, I'm really excited to see it continue to develop, and I can see this kind of a sensor system going even beyond rehabilitation, it seems. I mean, if you can replace a $60,000 motion capture system and get the reliable data from one sensor, that's pretty remarkable. So thank you guys again for making time available to be here and share these amazing insights. Hope we can continue to stay in touch and hear more about how things develop for you all in the future.
Yeah, no problem. Follow us on social media. And, we do a lot of work with students. Dr. Zhang and I both mentor a number of students, and the initial stuff with the sensor was done by a undergraduate student in Comp E. And so these are really great experiences, I would say, as a student in this competitive market, is getting research experience, getting lab experience, so that when you go for your job interviews, you're not just saying, I took these courses. You're saying, I did this. This is the output, right? I have made this. I was a part of this, which I think from an admissions perspective or from a employer perspective, that's what we want to see. Like, what have you done before, so we can look at it and see it.
Excellent,
then just-
excellent.
yeah,
Oh, sorry.
reach out if you have any, yeah, I was just saying, if you have any questions or you want to touch base in the future, let me know. I work basically all hours of the day. So it's, I'm typically available.
I went ahead and plugged various pages just to have them there.
Yeah, great. Thanks, man.
Good move, good move. I was just about to ask about that. So yeah, thank you.
Yeah.
All right.
Yeah, thank you guys so much. Thanks for listening.
Yeah, thanks a lot. I'm off to go play mahjong with old Asian ladies and try to make some money.
All right, everyone, have a good rest of your day and a nice weekend.
Ciao.